Hey guys, welcome back to the channel for a celebration of a new tool. Assuming you guys didn't read the description, this is a Creality CR-10 Max 3D printer. This is hands down the most expensive tool I've ever bought, and that's one of the reasons why we're going to make this video, maybe a couple videos about it, is to just kind of share some of that with some people out there that may not be that familiar with these things. So I'll be honest, the first time I ever saw a 3D printer in person was in 2007. I never dreamed there would be a day where I would even know how these things work. And granted, the one I saw wasn't anything like this, let alone be able to afford one for myself. Things have changed an awful lot in the time that's passed since then. These have, of course, gotten much more inexpensive, and the technology's been democratized and all that. But all the same, retail price on this thing's about $1,000. We want to try and get some mileage out of it for the channel. If you are unfamiliar with these at all, don't get too caught up in the weeds over that. The only reason this one is so expensive is because this one is so big. You can get more realistic size versions of this, at least realistic size for most people, for about $300, $250, $300. So our purpose in this video is to get the thing out of the box and get it put together and just kind of show you guys what these things are all about. And to share in the celebration with me, because this type of thing doesn't happen every day around here. So the first layer of our box onion is nothing too exciting here. It's got a big foam sheet on the top. Comes out, and this is the actual print bed surface. And these things come with this gobloads of packaging. These blocks on the side contain pieces, so let's make sure we don't throw those away. Now the fun trick is going to be to lift this thing out of the box. Probably going to need to grow some more room to do that, because this thing is pretty big. We'll see. So this is actually the bottom of the printer. And of course it's wired up. And what it's wired to is the controller right down here. So I kind of need to lift those out as an assembly, because the wiring harness is actually all kind of clipped together. So this is going to get a little dicey, especially since I don't really have room to put all of this at once. So I managed to get it all out of there. There's the controller. It's actually intended to screw down to this rail and kind of nest under it and all that stuff. We're not going to worry about that right now. Right now I'm just going to get the rest of the parts out of the box so I can get the box out of here, because I don't have enough table to do it all at the same time. So I got the box out of here, and I decided before I continue with what I need to do here, I want to take the bottom off, which is just held on with like a dozen screws, of this control board assembly, or this control power supply assembly, whatever, because after this thing's built, it's kind of hard to get in here, and if a power supply or something dies later, I want to be able to identify it. So since I did that, I may as well give you guys a little tour too. I assume this is the power supply for the bed heater, because it's the giant one. So this bed that you print on is actually heated. In fact, that's the heater right there. That is likely the power supply for everything else, or the extruder heater anyway. Yeah, it looks like there are wires that branch off of it over to the actual controller. I assume some sort of Arduino-esque controller. And then the front panel touchscreen display, little speaker that we may as well just disconnect because I'm never going to use. That's what's in there. A few cooling fans, a couple in the power supply, a little squirrel cage guy here. That's about all there is to it. I'm going to get this put back together and we'll move on to our next step. The next thing I want to do is check the condition of these idler wheels. This is what the whole bed of the printer moves back and forth on. It's on these rollers. And on some of these, I've been through a couple of these printers already before I bought this one. These wheels don't hardly contact the aluminum extrusion. Like that one's kind of loose, and this one's really loose. So I just need to crack those nuts loose and kind of tighten them up some, just so they're riding nicely on things. And that is kind of a pain to do. I've got to stand this whole guy up. And that sort of sucks, because this wire harness that goes between it and the controller has no plug anywhere. So this guy is always along for the ride with this thing no matter what we do. So kind of a fun juggling act to get this together. The nice thing is that inside this cardboard box of goodies they give us, they also gave us all of the tools we need to work on it, even if they are kind of crappy, but at least they're here. And I was just about to taint you guys with my ignorance on this, but the right way to do this is anywhere on the machine where there are rollers opposing each other, you'll find one of these cam nuts. And wherever one of these cam nuts are, if you turn it, it'll move the wheel inside and out. It's an eccentric. And just to give you a better idea of what I'm talking about, I took one apart. You can see the hole in that nut is not centered in the nut, and it's got a machined lip on it that fits in this hole, like so. So when you turn this, it moves the bolt in and out, which then moves the wheel in and out. So that's how you adjust all the wheel locations. So I'm going to work on getting that one troublesome wheel straightened out, and we'll catch back up. So I got my wheel straightened up. Now the move here is we need to flip this guy over and put this guy on top of this guy. The controller nests underneath it. See if we can get that accomplished. And something pretty much like so is what we're going for right now. And then the controller has holes in it that just line up to these holes in the extrusions, so we can screw it together. And that is what just happened, those 4 silver screws. I also very nearly crushed this wiring harness between the extrusion and the controller. Don't do that. But our next task now is kind of another one that's a little bit of fun. I don't think I showed you guys this part before. We have to attach our gantry uprights to the thing. So that big guy right there is what actually holds the extruder and runs back and forth. And there are just 2 bolts on each side that come up under each end of the extrusion. I'm going to get those chucked up in there. And it's kind of fun to get these screws up through the bottom into this extrusion because you don't actually have enough room to slide it up while it's on the table. So I've just got one leg of it off the table to give me a little bit more room. And I've got the 2 on this side started, so I'll probably just flip the printer around to do the 2 on the other side. And I've also just noticed I'm putting it together backward. I need to flip this 180 so that fan grate goes that way. Guess it's good that I noticed now. So I've got that all taken care of, including my oops, so now it's flipped around the correct way. Next step is these are uprights. These were what were stuffed in the packaging material, and they screw on to the top of the gantry up here, and then they come down and connect to this corner. We also have these T-plates, which install on the sides between this extrusion and that extrusion. So they go right like that, just to help stiffen that up as well. So I'm going to get that stuff bolted on, and then we're pretty much done with the heavy assembly. The hardest part is those 4 screws up from the bottom, and they're just kind of annoying. So we've got our uprights and gussets on. The only thing that might mess up anybody trying to play along at home is you have to pop the little plastic caps, these guys, out of the extrusion up here to get the T-nuts in for this bracket. And here in a second, we're also going to have to take these 2 bolts out of this upright to get the spool holder on the top of it. I'm not sure if the instructions really tell you that you need to do that or not, but you definitely need to do it if you want your spool of material up here, which I do. So that is the next thing I'm going to do, is I'm going to get those screws out and get my spool holder bolted on, and then I think we're going to be done with the mechanical assembly. Just we'll need to plug in wire harnesses and stuff to the stepper motors. Just got my spool holder all bolted on, got my bolts put back in, my little cap cover guy on. And now it's time to connect wiring harnesses. We have one of these on each side that goes to a stepper motor on each side. This ribbon cable and that connector need to be connected right there and right there respectively. Not a big deal, just get them clipped in and then we should be ready to power it up and start leveling the bed. So I got all my plugs plugged in, but I did forget one thing. The wire harness and Bowden tube. This blue guy back here is your Bowden tube. That's what the filament runs through. This actually drags on the bed if you don't hold it up somehow. I'm not sure what Creality's plan to deal with that is out of the box. They give you like a million zip ties to do stuff with, but I don't like any of that. And what we're about to do, I don't really like either, but it's going to be the easy solution for today. I have more advanced solutions on my mind later. But what I'm going to do today is just take some nylon construction string, make a little holder uppy to grab this guy and support it here, and tie it onto this extrusion at the top just to keep it held up there. In the long run, I plan to do something a little bit nicer, but it's a lot easier to do little crafty projects like this with a 3D printer that runs than it is without one. So once I get it up and going, I can make more stuff to organize this. And the same thing is true of this giant ribbon cable they give you. This powers the gantry, and the gantry goes all the way up these uprights, so it has to have all the slack in it, and we'll worry about a way to organize that a little bit later. Right now it's not going to stop us. So I'm going to get that guy tied up, and then I think it's time to power it on and see if we can get it leveled out. That's what my little string project looks like there. Not a big deal, just keeps it from dragging the bed. I think that's it. I think we're ready to get rolling. So I've got it plugged in. Let's see if it's going to power on and do everything the nice way. Moment of truth. No sparks, that's good news. Remember what I said about that speaker earlier? Settings, yeah, it'll beep every time you push any button. Go to your settings menu, minus the volume, and it'll eventually mute, and it should stay that way, which is good news. So now what I think we're going to do is just go back to our settings menu, go to move. We're just going to hit the home icon and see if the whole printer will home. So I'll give you guys a view of the bed there. So it came over and just hit a limit switch over here. So far so good. Well, that was interesting. The gantry just had a big step in it right there. But right now it's coming down with its little red rocket probe there and touching off on the bed. And its actual home position is like 10 millimeters up from the touch off 0. But what I want to do is see what's up with that left hand side of the gantry. So I'm going to come back down to our controls here. My Z-axis right now says it's at 11.6 millimeters. I'm going to take that up to 300. So it's going to run the bed up quite a lot. And let's watch it and see what happens. And there you can see our string's actually loose now, which is one of the things we'll need to address with our next iteration. But I didn't see it do like a jerky kind of motion thing this time. I'm going to home it again. It does seem to maybe have a hitch in it every now and then. I wonder if maybe these gantry wheels need addressed. Feel that one's turning, that one's turning, that one's turning. Something I'll look into more deeply when we really get to going. Could just be compression set from shipping too. So there could just be like a minor flat spot on one of those wheels. But anyway, I would say the thing works. So now our next mission is to get this bed leveled. And to do that, there are 4 wheels underneath the thing with these springs on them, and you turn those to adjust each corner. And as we go, that is what we'll be doing. The printer itself also has a menu we'll need to go into so it can run the extruder to various locations, so we can do that. But the first thing I'm going to want to do, and what you're going to want to do if you're trying to do this yourself, is make sure we have plenty of adjustment left. That when they put these things on, they didn't all the way crush that spring or all the way loosen it. So that's a good starting point. Turn the thing back on. We're going to go back to our settings menu, leveling. Now the extruder is going to home itself. So this is doing exactly what we saw it do before. Except this time when it's done, it's actually going to drop the nozzle all the way down. It's not going to hold it that 10 millimeters off or whatever it did before. So there you can see that's pretty much no gap in there. And the way I like to level these is with just a sheet of paper, although this thing came with a feeler gauge. Right now I'm just going to see if I can get this sheet of paper in there at all. And I can, and there's almost no drag on it. And that's not what we want. I want to be able to just barely feel it drag the nozzle. And since we're right in the middle of the bed, we're at position 1 in the leveling, I'm just going to take the Z and move it down until I can feel that paper drag. Okay, right there it's dragging. I don't know if you'll be able to tell or not, but that's actually, I think you can probably hear that even. That's tighter than I want. So I'm going to come back to my Z and hit plus. And if you can see it on the screen, it's moving it in 10th millimeter increments. So now there's basically just a little bit of drag on it, maybe. So the next move here is going to be to go into the aux leveling menu. So our auxiliary leveling. When I did that, I think the first thing it's going to do is home itself again. Yeah. Get my paper out of there. So it's going to home itself again. You guys have seen this happen before. So it homed itself, but it did the deal where it's standing off the bed. And it did that because it wants to know what point we want to go to level. So I'm going to select point 1 again, which should be right in the middle. And it's dropping the nozzle right down. Let's take our sheet of paper and check again. And there's basically no drag. That's okay. So now I'm going to hit position 2, which will move that guy all the way to this front corner. And I'm going to see how it feels. So we need to turn this wheel until the paper fits. Unfortunately for us, it's labeled. So it says that way is down, that way is up. What I'm not sure about is which way they mean up and down. I'm going to assume literally. And these are just regular threads, but I get all screwed up when everything's backward to me. So you might too. There we go. Now it's in there. And it has basically no drag on it. It's just touching. So that pretty much matches the position of what I had at my number 1 position. The idea here is you keep doing this all the way around the bed. You run through this a few times until you get the bed just so. And you might have to back out of this menu to adjust that overall Z height again, which would be this guy. So this takes a little bit of time to run through, but it's really not that hard. So I've got it just about right at each of the extreme corners, but the center has way too much slack in it. Like I can double this paper over and shove it in there, no problem. I could maybe even do 3 layers. But each corner just barely drags one sheet. So I think what's going on is that the bed's actually bowed up in the middle, and we can take it off of there and prop it up in the corners and just kind of push on it to try and get it to resolve that. But before I commit to doing that, I'm going to heat the bed up to where I would heat it to where I was printing to see if when it expands out it'll maybe flatten itself. And in fact, I'll probably heat it beyond where I would usually print with it, and just to see what happens. So to do that, just hit the back arrow all the way out to the main menu, go to temp, manual, bed heat. I'm going to turn it to 100, and that's in C, so that's going to be 212F. Let's go back, and we can see it coming up. It's at 21 right now. Probably take it a little bit to get to 100. We'll catch back up when it does. So I actually let this come up to 100C and then back down to room temp and then back up and back down a couple times, and nothing changed. I also misspoke. I said this was domed. It's actually dished. I was trying to come up with a reasonable way to illustrate that to you guys, just to show you how little change it takes to make a difference or to give you a problem. So I'm holding the adjacent corner down. I think you'll be able to just barely see this thing will move right there. And that is about the amount that we're out. So it's not out a ton, but it is out enough that it will cause us a problem. So what I'm going to do is I'm going to take this stack of 2, regular United States dimes here. I'm going to put 2 dimes on each corner and of course flip it over and then just push in the center and see if we can get some of that bow out of it. I'm using 2 because I think 1 will be about what we actually want to change, and then the other ones to compensate for the spring back and the material. So the Young's modulus of the aluminum, it'll bend and then recover to a point. We want to get it to where it's going to bend and stay permanently deformed, so we have to overbend it. So that's what I'm going to try, and if I go too far, we can undo it, especially for no more elaborate than our bending setup here is with just our stacks of dimes. We can do this a couple times with different stuff if we need to. I'm just going to give this a push. I'm not even sure if I can push it hard enough to really change it. Oh yeah, and right there, I've got the center of it hitting the table. I'm not even sure if I bent it enough. But I'll throw it on there and try it, and we'll find out. So I did my Rube Goldberg plate straightening system, and I didn't feel like it probably made any change. I put the plate back on, leveled it all out, and sure enough, it really didn't make a change. One thing I'm going to do is this thing does have a measurement function, where that little red probe in there will come down and touch off of the bed, I think 12 places, maybe 16, and will populate data over here and give us actual numerical data, so I know how far I need to bend it, and we'll also see how far out of square it is, and plus I thought it just might be kind of cool to show you guys. Let's go ahead and do that. We'll put it into its measuring thing. Down here on the menu, it's actually broken that out into quadrants, or not quadrants, because there aren't 4, there are 16. And it's going to come down and touch off the bed in each location, and then we'll have numbers to go with what's going on, so I can at least show you in math what my problem here is. So here's the data set that came back from that little leveling exercise. And you can see from this corner to that corner there's about a 4/10 of a millimeter difference. You can see from here to here there's about a 1/2 millimeter difference. And as we get in toward the center of the bed, you can see that those numbers are starting to get closer. But if we go to our extremes, that corner is really almost 0. I don't think I'll get any better than what you're seeing there. Kind of the same with this corner. When we get up to the front corners, though, there's a fairly significant difference between them. And we can see at the middle of the bed is probably our biggest difference. So our plate is still kind of cupped in the center. So I think I'm going to try 4 dimes stacked up as my bend fixture, and we'll throw it back on there and we'll see what it does. So I just did my 4-dime bending, and you can see our numbers now across the board are quite a bit more uniform, and I haven't made any other effort to level the bed again, so I haven't messed with the dials on the bottom or anything yet. This is looking like a lot more uniform distribution now than what we had, and this will never actually be perfect. That's the entire point of that probe, is that it can auto level, meaning measure the bed before each print and offset for it. But we want these as close as we can possibly get them, just to give it the best possible chance at, you know, a happy life printing that we possibly can. So I'm going to tinker some more with the leveling wheels and my piece of paper and all that crap and try and get it as dialed in as close as I possibly can. Then I'll catch you guys back up and show you the measurements and see how close we got. Well, before we do that, I think we got another problem to address. The extruder on this thing is just ultra loose. These wheels need adjusted. That's not right at all. That should be much better than that. I got to get that fixed up before we continue on. So we're still dished in the center, which is no big deal. I can bend my plate some more. But something I noticed is there's some mung on this actual heater plate. There's some adhesive right there. So I'm going to take to this plate with some acetone on a rag and just get it nice and clean. I'm going to do the same thing for the bottom of the other plate and just make sure there's nothing on here that's holding us up. And I also noticed, and I kind of expected this one from the other printers like this I've used, is some of these wheels aren't lined up very well on the belt. So after this thing runs for a little bit and breaks in, I'm going to keep my eye on the position of these wheels as compared to the belt, because I might have to kind of space them back and forth. And that's just stuff you got to deal with hobby printers like this. You know, if you spend 100 grand, they'll be tuned in right out of the box. You spend a few $100, this is what you get. So after just a whole bunch of screwing around for about 2 hours, this is pretty much as good as I can get. The biggest difference you're going to see is about a 0.5 millimeter, and everything else is about half again tighter than that. And it should be fine, because what I'm thinking the printer is doing is when it builds this table out, it's actually mathematically leveling my part to those dimensions. 0.5 millimeter is not much. If you are more accustomed to the imperial system, that's about 20 thousandths. And if you're not accustomed to measuring stuff at all, that is what it looks like in reality on me Harbor Freight calipers here. For reference, this is 1 United States nickel. As compared to the gap in the calipers, you can see this nickel's about 3 times as thick. Just for fun, we'll go ahead and measure it. Looks like my eyeball micrometer is about right. This nickel is about 3 times as thick. So I have the bed on the printer mechanically leveled to within 1/3 of the thickness of this nickel. That's pretty good for not being precision ground or really a precision machine. So I think we're ready to try and print something. For reference, this is my stack of change I used to level this thing up. That's 3 $1 coins. It looks like about $1.25 in quarters and a nickel. And that stuff stacked up measures out to just about 3/4 of an inch, or about 20 millimeters. So I had that plate picked up by 3/4 of an inch on every corner and was smashing it down to get it as level as it ended up being. Not what I expected, but I think it'll work out okay. We're going to find out and see. Okay, so I got her loaded up with some white Hatchbox PLA, because I've had good luck with Hatchbox in the past, and PLA should be a nice trial run. The only upgrade I've made to the printer out of the box is to adapt the micro SD to a full-size SD card receiver, because micro SD cards suck and annoy me. Otherwise, let's just get down to it. So we're about to start printing, and I'll warn you guys that I'm not expecting this to go awesome. It's our first print with a new machine, so no reason to think it'll be great. But all we're doing here is printing like a 10mm by 10mm block, one in the middle and one at each extreme corner to just use as calibration parts. And when I say that, that's just to verify dimension and to make sure it's going to stick to the bed okay. This bed is extremely difficult to get parts off of. I already know that from the others I've used like it. About 11 minutes, I'll know how it's going to go. Actually, I'll know how it's going to go sooner than that. This is about an 11-minute print. So we have some pretty significant problems right out of the gate. The worst of which is my slicing software, I'm using Cura, apparently has the bed size on this thing wrong, or I sliced it wrong, and it's actually trying to print off of the bed. Also, we have no adhesion in the middle. That's why it's not a nice shape. Same problem down here, it didn't stick at all. That's the only corner that worked well. So this is exactly what I expected. This is just how it goes when we're tweaking things. So we need to mess with our bed leveling stuff a little more and just keep dialing in, dialing in, dialing in. So after much playing around with this thing and a whole lot of different trial prints, I just cannot get the thing to consistently print on dimension. To illustrate what I mean, this is supposed to be a 10mm by 10mm by 4mm tall block. And what I'm actually getting out of the thing, 10.6, the other axis 10.4, 10.3. checking thickness, 3.7. So what it looks like to me it's doing is it's smashing down too much and spreading the first few layers, and then it's not getting that material height back as it prints. And I've tried all sorts of things so far to try and get this condition to correct, and it just won't. I've also printed this part on a different CR-10 Max, and it printed just fine. So what I'm going to end up doing now is take apart the whole Z-axis on the thing, because I think something's up with the height from side to side. And while I'm at it, I'm just going to tear the X-axis down too and just look at everything, because this is how Creality assembled it, in China a year ago or whenever they did it. So I don't really know the condition, all that stuff. I've got the Z-belts just singing tight and way tighter than they should be. I've tightened up everything as much as I can. And I think that the issue is this thing might be binding, and sometimes I think I can even see it. But that's going to make this video way too long if I start tearing apart the whole thing and all that. So we'll do a different video where I get into trying to fix what's wrong with it, including why the bed's so out of level. I'm going to end up tearing the Z apart too, just to see if we can get that so I don't have to have a completely bent plate on it. So guys, I'm sorry to catfish you a little bit that we're not going to do any printing or anything in this video. This is just kind of the unboxing and assembly video, I suppose. I have experience with several other Creality printers, and they've all pretty much come out of the box just fine. So of course, the one I buy for at home, the most expensive tool I've ever bought, is the one that's screwed up. So it is what it is. It'll make for fun video content. As always, guys, I appreciate you stopping in for this video. I'll see you on the next one. I'm Max, that's Saddington Bear, and we make videos like this all the time. Here are a couple links to some other videos we've made, and we really appreciate you guys stopping in.